Stream Share shelf tool is finally working. If you do !hip, you can go to this link. I have some kind of confusingly written documentation. All you really need to do is download this shelf tool. If you're really new to Houdini, just go to save link as, and then in your home Houdini directory, I believe that it would be config, or maybe it's toolbar. You could save it in that path. And those instructions are actually written here. So just home Houdini XX is like the current version. You can also create these shelf tools yourself if you're a more advanced user. So just anywhere in an empty shelf area, you can do new tool under script in Python. You just paste that code and you should be good to go. I don't think they'll break with Houdini 19. The reason they actually were, I thought they were working, but they had broken again last time, was due to the Twitch hack or the leak or whatever that was like at the start of the month. I had to update my credentials and my like open authentication key or whatever that script uses. But it's all advanced, boring technical stuff. So we'll get into the Vex now. But yeah, we do have the shelf tool working. So throughout the day, I'll be sharing the scene with you, and you can get it in the chat, which I think lends itself really well with Vex code, especially. It's easy to get. This is just a really tiny box that we're dealing with here. There was actually Houdini 19. They said they would have some more like line numbers and font size controls and stuff like that in this box. So maybe their Vex editor is getting an overhaul in 19. But just to keep in sync with it, if I share the scene with you, it's easy for you to get the code that way for sure. So yeah, we're gonna go over some look at techniques and stuff like that. Houdini 19, soon, brother. So we'll do that. We'll do a sphere. And I'm just gonna do a quick old school expression with this sphere. So on translate X, we can do sine of $FF. If we do shift click on this, you see we get a sine wave. Cycle, boom, boom, boom. This one, if you divide it by $RF end, I think I actually want to like multiply it by that. Then you get a cycle. You should get a cycle like every 2 frames. Might be getting my radians and degrees and stuff like that mixed up. Am I doing multiplying this by? $RF end is just the end frame. And then if you like divide, it's possible I was multiplying by 360. So now every frame, this will be a sine wave, like one repetition of it. So the 360 is conversion from degrees to radians, basically. Zaxbox, thank you for the tier 1. Let's go. Yes, and if you don't, people are new here or anything like that, or if you're new subscribers, if you link your Twitch to Discord, you would get access to the bonus content. So that's highly recommended as well. Recently was doing some generating some inflated balloon shapes and stuff like that with Vellum. So if you just link your Twitch login with your Discord, you'll get access to this bonus feed channel, which is really cool. Subscriber bonus. All right, so multiply this by 360 so we get a cycle every frame. And then if you want to do maybe every second or every 24 frames, you can divide that by 24. So this isn't actually Vex that I've done yet. This is just HScript, but it's useful for quick expressions and stuff like that. So I'm just gonna Control-C copy that, go over to the Z parameter and switch from sine to cosine, but use the same numbers. So if I play this and put on my real-time login, we get a sphere that's going in a circle every second, every 24 frames. Hopefully that makes sense. So you offset these sine and cosines, and you're basically drawing a circle. If you look at it in one dimension, with maybe like no perspective, it just looks like it's going back and forth. But then combining the two dimensions, you get the full circle. If you want, we can multiply this by bigger numbers to expand the radius of the circle. All right, so that's cool. And then height, I'm just gonna lift that up a little bit and do maybe a full number. And then over here I made a grid, and I'm going to use Vex to try to reorient these pieces or the grid panels so that they're always looking at or facing, so that they're reorienting themselves to face this sphere or this target locator. Before I do that, I'm going to maybe just reduce this 48 frames, 2 seconds. So just slow it down a little bit. Steve, few hours. Someone needs to call Side Effects and ask them what clock, what time zone are they obeying. All right, so he slowed it down. I'm gonna make this a little bit bigger. And if we go to wireframe, we can look at our faces. Let's increase those. And we should be good. Filed a ticket. Where's my Houdini? All right. I usually do this. This wrangle here is actually empty. I haven't used it yet. I'm just going to move it down. And this assigns a unique primitive number and just copies it over to an index attribute. So we're just copying the actual face or primitive index into an attribute with this node. Super simple. And the reason to do that, or that I do it sometimes, is if you want to do like extract centroid, this requires an attribute. So if you just use that index, now we get a bunch of points. And maybe before we make these points, we want to assign normal attribute. If we set this to primitives or faces, then we can transfer that normal attribute to these points. And we can see our face directions have been preserved or copied to the points. So I think they have to be on primitives. If it's on other parts of the geometry, you might not see them. And then with this wrangle, it's empty. I'm just going to connect the auxiliary input here to our spinning sphere so that we can more easily reference that input. And then this might be a good point to do our first handoff, just if anyone got joined late or got lost or anything like that. This is October. Let's see what we're dealing with here. 27th. We have ourselves a wonderful 27th. All right, I'll just call this Vex look at targeting. All right, let's give this a try. Ooh. All right, it worked. So this worked, and then the shelf tools, if you could either just click on this link as well. Your web browser would like maybe give you a download prompt. If you don't want to deal with the shelf tools or any of the scripts, you can just grab these manually. The reasons I set up the shelf tools and stuff is it makes it a lot easier to stay focused on your scene, and you don't have to deal with files and opening new Houdini sessions and everything like that. All right. Yeah, Redshift is a bit unfortunate that they're I was trying it with Metal or the Mac Redshift build as well, and they still haven't I don't think they've gotten OSL programming or shaders or code to work on their Mac builds yet either. Minor personal grievance. All right, so you get that file, you should be seeing what I'm seeing now, and we'll start doing our coding. So we'll have a vector that will be our target pose or position. I'm just going to set that equal. I'm going to use this point function to retrieve the point position attribute from this auxiliary input. So on these inputs, you can actually see when I hover over it at the bottom of my network, it gives you point and then the number or the handle index to use. So this primary or main input is 0, and then they start counting from here 1, 2, 3. So it's a bit of a, takes you a little bit to get used to if you're new to it. So 0 would be myself or the current geometry, and then I would use 1 to pull from this input. Then we're going to get the P position. So if we just middle mouse button on this, if you had other attributes like color, velocity, or that kind of stuff, you could grab it as well. And then you can just use 0. We only have one point, and that point index is going to be 0. So they like counting starting at 0 and incrementing from there. Like computers generally count that way, even though as humans we usually start counting at 1. Sometimes they don't obey that rule, but for the most part they usually start counting at 0 and going up from there. I'm NYXD. I'm doing well. How about you? Got some British baking? Cooking all around. All right. So this is just a target position. If you want to, yeah, you're curious to see where this go. I was unfortunate. There's actually a reference thing that I saw on, I believe, I don't even remember if it was Twitter or Instagram, but then I tried to find it this morning. I couldn't find it. I thought I saved it. I thought I liked it or hearted it or whatever. But yeah, I'm kind of headed in a direction if you're familiar with it, someone had a red sphere that was like incandescent, and they had some stuff shifting and translating around and stuff in accordance to proximity of that. So this is basically getting in that direction here. All right. So let's, if we just want to test this, we can overwrite our current position, just at P. This is how you write two attributes. If you use this at symbol, you can read and write from your attributes in the main input. So if I set P to target pose, all of those points snap, or they just get overwritten, they get moved to the target position. So that's pretty cool. We can do that. If you want to target the direction, that's a bit of maybe linear algebra, Pythagorean theorem or something like that. But you basically use just vector subtraction to give you a vector pointing in a certain direction. So I can overwrite the normal. If I just set it to 0 like this, you'll see they go away. But basically you want to do the direction, your destination, which is going to be the target position, and subtract that from where you're currently positioned at or looking from. So that's 2 minus from. So the from is going to be our current position. And you can see now they're all pointing at the sphere. And I go by Zach. Good morning. This these vectors will actually point, they extend to the center of this. They point exactly to the middle. If I press the D key over the viewport, Houdini actually scales these normals to be 20% of their total length. So if I set it to 1, now we're visualizing the full direction. So be careful about that. I guess if you're using normals to debug your vector attributes, is that by default they're scaled. Usually so that if you look at traditional geometry, it would just get too messy or too confusing if all of the normals were drawn at 100% scale. It would be too confusing or whatever to look at. So that's why they default that to just point to or whatever. They did it? They did the 19? I don't know if I see it. Ah. I think I see it. Let's get this churning in the background. Maybe we'll pop it open after we do our exercise here. All right. Yeah, it is out. I just checked. I was able to download it. It says 20 minutes left, so their servers might be moving a little slow. Oh shit, yeah, I forgot. I should probably do Python 2. So I think if you're using Redshift, or I don't know if there's a Redshift plugin or whatever, but usually I still am sticking with Python 2. So just under production builds. you have the option up here to switch between different builds. Yeah, I think the Redshift team is too busy to to switch over. All right, so we get that churning. It says 14 minutes now. Okay, so these targets, even though the normals are scaled, we're imagining, or you know, that they're going to the center. We could actually copy this, and I'm going to make another vector variable, and we'll call this target dir for direction, or dir. Put it like that. So this just makes it a little bit easier to reference. You can do it like that. It's kind of like a shortcut. These variables, important to keep them different in your head from attributes. They don't get stored or updated on the geometry, whereas this at symbol and attribute bindings, these do get written or saved kind of permanently, passed along in the geometry, whereas any variable that's declared like this, purely temporary, just for internal coding, just for this particular snippet of code when it runs. All right. Then we can do another thing that's pretty cool with this direction. You should have let your download finish before you notified all the chatters. you DDoSed yourself. All right, so you could do length, and the length is a pretty cool function as well. Purely Pythagoras theorem at this point. And what this does, I actually have this color bar exposed here that I can adjust the brightness. You can see if I change the gamma and exposure of the viewport. If you want to get that color correction bar, you just go to your perspective and you enable it right here. Color correction. So this is length will measure the distance that that direction is pointing, or the magnitude, the strength of that vector. So this is how far it's going to have to move to reach the target. So you can see we have a nice fall off pattern that we're getting from that. So we can visualize it this way. Sometimes what people will do is they'll do 1 divided by, and this gives you more of an interesting fall off. That's like intensity here decreasing, and if you want to do a power function, maybe this to the power of 2, which is just multiplying it by itself, then you get an even more exaggerated fall off. And this is almost like a lighting equation. So we almost have a fake lighting effect here, like this is emitting light. Tonib, did you find it? Oh yeah. Yeah, this is the one I was thinking of. I forgot to save it. So yeah, if we do everything right, hopefully we'll get close to something like this in a few minutes before my Houdini 19 downloads. So yeah, this is kind of where I was getting this idea from. We actually just discovered that the link went live, so I have it downloading right now. But I haven't pre-watched, I don't know the strats for Houdini 19 yet. So this is this function here is actually a popular function that would be like maybe quadratic decay. You can see people graphing this fall off. It's actually used for lighting, I believe. And this is referring to the way that light attenuates over space or distance. So you can see basically this white to black fall off. How this curve goes is dependent on your function. So if I just change this back to 1, this is like a linear fall off. So there's no curve happening here, or no interesting kind of like exponential, anything like that. If I actually go up to 4, change this brightness, then it's like super exaggerated or whatever. So you even have controls to play around with. This is a cool way to remap your distance, or like redistribute everything like that. So that's pretty cool as well. So we're basically saying, based off of the distance to the target, we're gonna do this exponential fall off. If you want to graph any of these functions, like we were just checking out some graphs online, I usually just make a line. I just leave it pointing up in Y and leave this at 1. And you can change your points here to whatever, like this is just going to be the resolution of your curve. So it doesn't, you just make it a big number and you should be good. And then if you do a wrangle, I'm just going to set this to X from the Y position, or the height of the line. And then if I say P dot X equals X, we get this thing pointing over diagonally. I'm going to go into the front viewport for this. Turn this grid lines on. And we do P dot Y equals X. This is very traditional graphing calculator, TI-83, 93, whatever, plus syntax, or your Y equals X, Y equals MX plus B, all that stuff. So if we take this and do 1 divided by X, this is what our first fall off would have been looking like. And then if we do power of X to 2, you can see that was like our more exaggerated one. You can also multiply this at the end to change your intensity of the light, or of the curve, or anything like that. So this is, you can see it just spikes up really quickly when it's close to 0, the distance is close to 0. If we're close to the light source, or the target in this case, and then it quickly drops off or falls off. So this is just a handy way to graph any of these functions or anything like that. So you can do one minus X, and that just gives you the linear drop off. You can do 1 divided by X, then that gets you a little bit more of a funky fall off. And then you can do the exponential to get even more dramatic stuff. You can change this as well. We were saying you can adjust your exponent to get different degrees of roll off. All right. So this is the function that we were doing, the equation. We can do... Let's just make a new variable for this. I'm gonna just call this a mask. And let's take the current position and let's lerp, where this is just gonna mix two inputs according to your amount. So in this case, I believe I can use the mask. So we'll take the current position. Let's mix it with the target position based off of this mask. So now we have this kind of distortion stuff happening. Pretty cool. Yeah, I believe you can actually scale and see your line numbers and stuff like that in the Vex editor. It's pretty cool. So we can adjust this exponent, and we can also adjust kind of the intensity if we change this multiplier at the end. You can even kind of overshoot stuff and get interesting effects as well. So we have our roll off if we want super sharp, pinchy stuff, and all that. You can also use custom ramps if you want to. Might get to that later as well. All right. So this is just how we can use our mask, or why we're storing that and calculating that and saving it. So if anyone's just getting in, Nedits, you can get the file I'm currently looking at here. We're working on seeing how we can get to something maybe close to this or similar to this kind of look. Can actually maybe leave this just tucked away down here. Alkama. It's like some BBC library. This is some Carl Sagan. We're off in the cosmos. All right. So let's get back to our target direction. And turn our normals back on. So we're going to try to do some of this rotational updates. And I think you already busted open Karma? Oh, my network disconnected. You guys are hacking me? Is it stealing all the bandwidth? Must be on a T1 line over there. All right, so we'll try to transition some things over. I'm gonna get out of this like debug mode that I was in over here and just update things a little bit. So we're dealing with solid surfaces or pieces instead of points. So I'm going to take the grid, I'm going to unique the points. This just does kind of what the icon looks like. It just detaches, unwires the faces from each other. So if we look at point numbers, the edge points are unique points. So if you do a jitter, point jitter, all of these are free, or they're not connected from each other. So if you do it with that, so this just disconnects all of the faces from each other. So we do that before we do assemble. And the reason to do that, if we're going to pack everything, we're going to end up with a unique piece for each face. If we don't do that, we just end up with a unique packed primitive or piece for the full grid. So unique, and then you get a packed prim, packed geometry for each face. We're going to want to make sure we have these normals as well, so we have the initial direction faces are looking at. Let's just do it like that. Oof, turns black. I think we can fix it. I'm gonna transfer. I think maybe in this case, I can maybe assign them to points. And then when I transfer them, these will be on the packed primitive points. So that's actually what I want in this case. Should be good. And I think we should be good to go. So I just hold Alt and drag to make a copy here. And I'm just going to start with this code again and reuse portions of it. Sometimes when you're dealing with packed primitives, you can see I don't have the normal attribute, like it doesn't show up in the viewport. There's a few ways you can get around that for like debugging purposes. You can just delete geometry but keep the points, and then you'll see the normals again. You could also unpack. Then I would need to transfer that attribute with it. So there's a couple options. You have to make sure that those show up. I think maybe they fixed it in Houdini 19. Fingers crossed, but I have a feeling that it's not fixed. So what we'll do, instead of updating the normals now, I'm going to try to actually update the primitive intrinsic. So when we pack these geometries, we actually get their transform that's encoded as a matrix. And I think we can do this, maybe we'll just start with a super lazy way. We'll do set prim intrinsic 0 for this main input. We want to set the transform intrinsic, and we want to kind of instantiate or create a matrix. You can actually use something, I think it's the make transform function. This will create a matrix for you. You just need to supply it with your direction. That would be the normal n and up. So this is like your 2 pole vector, 3 right hand system situation. So we can do target direction for our direction, and then the up vector, you can use curly brackets and do like 0, 1, 0 for y or for your up vector. And let's see how this goes. So I think we need to tell it what primitive we're assigning this to. You can use primnum, and then we're good, it looks like. Unfortunately, I can't see any updates to my intrinsic. Let me make sure that this is giving me a matrix 3. And I might actually want to switch this. Let me try the look at function. Yeah, mine's still saying 14 minutes. You guys hopped in there on the express lane. So if you're ever, oh, it did update. The hell is going on? It might have been a viewport delay or something like that. Oh no, so just switching to the look at. Look at did work. Yeah, I'm sorry. So that's the change that I made. And if you want to check this out, you can see the usage over here. I just type in the name of the function and then Vex into the Google search or whatever, and it usually shows me the page in the first hit. So this is actually saying it wants it to be in this from to format. So instead of doing it this way, let's try setting it up kind of the proper way. So from is going to be the current position, and to will be the target position. So I think that's just kind of rotated a little bit differently. So that's pretty cool. And then I don't think we need this to explicitly cast to matrix 3 anymore. I think it's smart enough to know what we're doing. Basically, if this function depends how many, like if it's a veridic function or the how much what it returns varies, sometimes you need to explicitly tell what type of data type you're expecting out of it. You can do a Google search on this veridic function. But it's just a function that can give you multiple data types back, essentially. So I think maybe this might actually be overloaded function. Something of that nature. All right. So we're just assigning everything to this direction, this look at direction right now. Let's try to get a little bit more creative with or let's give ourselves more capability to control basically how much these are pointing, or I want to be able to blend between the current direction. Veridic, yeah, I think that there was some name that it might be overloaded, but so basically, like in your include, you have all these functions are the same name, but you have one that can return a float, you have one that can return a matrix, you have one that can return a quaternion. So if you're calling these functions, then you need to sometimes explicitly like cast or preempt like the data you're returning, but it's a little in the weeds for what we're doing right now. Polymorphic? It might be. It's like a with polygonomorphic. All right. So instead of explicitly setting it like this, I'm gonna rewrite this code a little bit, and let's actually get the current transform or X form from the geometry. So we have that, and then we have you'd call this look. You could call it like something else. Maybe look might be good. And then if we want to blend these, we can blend them. We're going to want to use quaternions for that. Because quaternions, they handle interpolation of rotations the best. They have a function that's called the slurp. It's a spherical. Somewhere in Houdini, Cinema 4D Artist is gloating. Yeah, they do have the MOPS toolkit, and there is maybe less coding, scripting ways to do this. But I think you unlock a lot of potential inside of Houdini if you get familiar with a lot of stuff going on that's under the hood, especially when it comes to kin effects and that kind of stuff. All right, so we have our two directions, and we'll say this X form matrix. We're gonna interpolate between these two matrices. So I'm basically extracting only the rotation when I'm converting or casting them to quaternions like this. So let's do this one and this one. And then let's just start out with like 0.5 for our blend amount. And then I can set the blended right there. So 0.5 is the amount of blending I want to do. So what I've basically built in here is we have a single control of how much we want to blend this. And what I'm basically doing is extracting the rotation and casting these transforms to be just rotations, doing my rotation blending or the spherical linear interpolation, and then converting back to a matrix with this last function or this last call. So there's a little verbose or complicated, but when you're dealing with packed primitives, if you want to directly go in and manipulate them using Vex, it's pretty powerful. All right. So instead of doing this number, we can actually use this mask that we created earlier. And then we're only adjusting specific range or radius or fall off of these. So we're maybe on our way to getting something like that, but let's maybe keep pushing. I think what I'm gonna want to do with this mask is maybe control it a little bit more directly. So I'm gonna try setting this up using a ramp. We'll just call this mask fall off. And you can pipe in the distance, the length to the target direction. and build our ramp parameter. So what's going on here is that this is going to cycle. Every time this length goes above 1, it's going to just start again at the start of this ramp. If you want to avoid that, you can use this clamp function. And I think we want to maybe multiply this by like a smaller number. So we're kind of squeezing more stuff into the range. And then we could change this ramp around. I lost the first one. I might have multiplied this number by 2 left. So we can do this. You can even go with these numbers above if you want to do some really wacky manipulation. And then you can change this number here to adjust kind of the roll off like that. And I don't know if maybe I might try real quickly. Oof, this download's really ripping. Snuck up on me. Volume torus? I don't see it. You see these in my network somewhere? Corignan, how's it going? I think maybe this lookout. It's trying to give it an up vector. Trying to avoid some of this like rolling that we're getting, but Studio Not War, thank you for the tier 1 1-year anniversary. Let's go. Thanks for sticking with me. Sorry, it's been a bit of a busy year for me with work and everything like that, but desperately trying to get back into the more of a routine with streaming and everything like that. So I'm gonna switch this. Maybe instead of look at, let's try again our maybe make transform. And then I think we're gonna want to go back to, let's try doing it this way. We have our up, I'm gonna set the up vector first. And then I'm going to use the target direction. Yeah, I'm not sure. I thought that would be... I don't know. I'd expected to see something changing. Let me take one more look here. I don't know. Not exactly what I was after. All right, I'm just gonna go back to what we were starting with. No, I think this should be okay. I'm just gonna tweak this ramp here to try to get something closer to here where they flatten out. Then they get a little bit more jumbled up, and then we can even leave our last key here to let them get a little bit mangled up as well. Technically the close one should still point up, and the distance ones should rotate. Yeah, I think, I'm not 100% sure. Yeah, the goal is to orient them towards the target. That's what I was at least expecting to see at the start. We could try to do this. Yeah, that's what I was thinking. It was because the initial transform, but pretty sure that this is just identity matrix because I was just dealing with flat geometry or whatever. We could do this one more way. Let's just do that quickly. So I'll just redo the X form like this. I'm just gonna set this up using the rotate function. So we'll rotate based off of this mask. This will be the amount we're gonna rotate. And then this, we're gonna want to multiply it by pi because this rotate function will work in radians. And then we can have this point in the target direction. So that's the rotation that we'll apply. And then we could take a look maybe instead of using our ramp, see if we're getting something closer to it. So I think that's starting to work out maybe a little bit better. Yeah, we had at the start of the stream we had some normals or lines that we were adjusting. If you take a look at this one, dealing with these, it's a little bit easier because this is a vector direction. Dealing with this stuff, it's a little bit more difficult because you're dealing with packed like intrinsics. There's a matrix rotation. I think I'm a little bit closer with this. So if you want to look it up, whoops. You can check out the function here. So this is the matrix we're rotating, the angle, the amount we're rotating it. And then the axis is this vector here is the direction. I'm sorry, the amount we're using, like this version of it. Player 2. Thank you for the 16-month streak. The OG. You got some nice flair going on there. This might be the best way to do it. Sometimes that pre-rotate helps if you're dealing with scaling and other matrix operations as well. So I'm going to switch back to this mask version of it. The axis should be orthogonal to the target. Oh, I think you're right. Ooh, there you go. Thank you, Alkama. So yeah, if we go back to our original one, this is definitely what I was expecting to see. So you use this cross product, basically have a direction, and then your up vector, and it will give you a orthogonally positioned vector to that. So when you rotate, you want to rotate around like an axis. I was getting myself confused going between the look at and the rotation or whatever. But I think we can get rid of that. Chop it out. I just need to declare this, and we should be good. I think I don't need to multiply by 2 pi. I think I just need to scale this by pi. And then we can go as crazy as we want here and make our own interesting fall-offs and stuff like that. No Vex coding for Karma. I think depending on their OSL integration, you might be able to cook up some crazy volume shaders in OSL. The Redshift one's super limited, but in other renders that have a more robust OSL implementation, you definitely have access to like the Heine Greenstein different volume BSDFs, and you can do some interesting like manipulation with them for sure. The ground form a letter? Yeah, you could do interesting stuff with the ground for sure. I think I want to normalize this result first. I was seeing some skewing of the matrices or of the transform. Yeah, for sure. We have lots of different options. So Juan's asking about having the ground form a letter. Instead of doing this rigid look, we can do a more, of course you have control here if you want to change your divisions. You can change your amount. To get different looks for sure. But we could also do like maybe a different grid that's just a quad, where it's just a single face. If you do the font node, you should rotate it to be flat like that. You can do A. Usually I switch up here to Helvetica just for a more geometric character. And you could do maybe like scatter. Let's just do 25 points. And then if we fracture, Voronoi fracture, based on some of these points, you might need more. And then sometimes with these letters, if you drop a remesh inside, if you triangulate your letter instead of dropping points on like a giant quad like this, you'll get a little bit better random distribution or whatever. Or you could even try this relaxed iterations for sure as well. So you can do that, and then if you want to get rid of some of this business, I'm just going to uniformly scatter some on the grid and then merge these point clouds together. So you might need to play around with this according to your liking to see more or less points. And then the size of it might have some effect as well. That's one thing you can do. Sometimes as well, I find if we, instead of scattering points inside of the letter, let's turn off whole faces. I want to get rid of that internal division right there. So in order to do that, we can't whole the faces. And then if I just resample, we'll just make a bunch of points along the edges like that, and we can use that result and maybe get something cool. So you kind of get letters this way. You could do some. You could try some stuff with the Boolean, and actually cut out the font or the letter directly if you want to see these a little bit more clearly. Maybe something like that could be cool. So we kind of get something interesting there. All right. So I'm going to try to get up into this reference. This is how you could do it. Hopefully you get some ideas maybe from this one. But yeah, thanks for asking. If you want to play around with this, you'd do your own, conduct your own experiments or try some stuff out as well. I'm gonna get rid of this stuff and just do these purely random, maybe with a bit of relaxation. Not a ton. Still want it like somewhat organic. You can also play around like this. So if you merge some purely random into like your uniformly random, you get some kind of mix of the two or whatever. So that's pretty cool. So something like this could be a good starting point. I'm gonna doctor this stuff up a little bit to get it looking a little bit more like this, more stylized. So we do subdivision. 19 is out. Yes, I think my download is done. Might crack it open and do a quick test after this. After we wrap this up, so just get cracking. So it's do maybe a resample before we subdivide. This just lets you preserve more of the hard edges. So we can kind of control how much smoothness or whatever we're getting. WM Clark, thank you for the Prime. If you don't know, you link your Twitch account with the Discord here, and you'll get access to some bonus setups, some bonus files and stuff like that. I've been posting the same stuff as my Patreon content. There's also a back catalog at the pinned message at the top of that channel. So if you're subscribing, you get access to that. Pretty cool. Cleanup Yak, thank you for the Prime. And yeah, if the Prime, you're linking your Amazon account with your Twitch. So you link your Amazon with your Twitch, and then Twitch with Discord, and you get all the benefits. All right, so we got that. I'm gonna do a poly extrude. I'm gonna do this after we compute the normals. So I want these normals to always be up for all these shapes. So let's do that. Gorgeous Gabe, thank you for the tier 1. Let's go. I might actually switch this. So I'm gonna do this. Can add some divisions maybe. I might do a remesh. Thank you, Gorgeous Gabe. So we have a remesh. And we have some edge divisions. This will let us do a blur. Like that. If we visualize this here, we have something, I don't know, somewhat close. You could play around with it. If you do maybe different blur adjustments and stuff like that, you might get different qualities of things. All right. Maybe after I assemble this, you could do attribute transfer if you want different normals on your packed geometry. So this is just going to copy over these normals here. So I basically just wanted to keep track of this. If we visualize this again with the add SOP, just to visualize the packed geometry, just keep track of this. If we do I ran out of time, but my goal was to maybe do this with like a torus or three-dimensional geometry or something like that. Maybe we'll do it later with that normal vector. Okay. So we're nearly there. Let me slow this down. Like that. And I'm going to try to reduce the vertex count of this stuff a little bit. Just try to speed my playback up. Was I including this back? All right. Oof. A little gnarly. All right. You can add some lag. I'm not a big fan of going into chops too much. I find it kind of slows. It's kind of hard to work with it. It kind of slows things down. I might just add. I'm going to try this attribute noise and add noise to this position here. So sphere is kind of swimming through a noise field. Maybe the Houdini 19 chops is a little less crashy. One thing you might want to do with chops is like filter out some of these quick turns and that kind of stuff. I also realized I've kind of run out of time to dive into chops for the end of my stream window here. So let's just kind of speed run this. And let's move this down a little bit closer to the grid, like this. And maybe we need to do some tweaks with our ramps here. I don't know if we could try negative numbers. If we want it to rotate the other way. You can actually expand the graph editor here if you want a little fancy business going on. Getting real engineer mindset. We could leave this completely flat, or you could go. I have a feeling it's something. Kind of close to this. Hard to say. And I'm gonna do something. So let's just name this. I'm gonna try something kind of sloppy or quick. So I'm gonna instantiate or initialize just a white color here. And then I'm just going to use this attribute transfer to spatially blur or do like a fall off. I might need to unpack. Sometimes the packed intrinsics don't always show up that well. You could also maybe promote to primitive your color, and that will solve the display issues sometimes. If we want, we could change this to that kind of dark looking stuff. Not as good as a render for sure, but just gets us a little bit closer to that kind of look. Kind of close. So I don't know. Hopefully you guys find this kind of exercise or practice helpful. You can learn some interesting techniques and stuff from this for sure. Lots of interesting potential and stuff like that. So yeah, let's save this. I'm just gonna version up. If you guys want to pull in the latest or this, play around with it, go wild with it. Let me try to see if I can get this Houdini